Hello everyone. Welcome to our video tutorial for our Fundamentals of Cyber Defense class. In this video, we will explain what Wireshark is and demonstrate how it's used as a network traffic capture and analysis tool. Wireshark is a packet analyzer, used to see what is happening on a network at a microscopic level. Packet capture is vital because it allows professionals to identify misconfiguration and spot malicious activity. For example, it can be used to investigate malware or monitor for unauthorized data exfiltration. Before the demo, let's define some key terms. Network traffic, the data moving across a network. Packets, small chunks of data used for transmission. Protocols, the rules for how data is formatted, like HTTP or DNS. IP addresses, unique identifier for devices. TCP, UDP, core transmission protocols. TCP focuses on reliability, while UDP focuses on speed. NIC, the hardware that connects your computer to the network.
So, hello there. But now we're going to show how the software works. So first we just type Wireshark, or then just type Wireshark, and then you're going to have your interfaces. So in the interfaces, you're going to grab usually your video card. Here in KDE, you could check on this side which interface you're using on your device. But usually you will have an interface for the loopback, and also if you have any virtual machines or virtual devices. So we grab it here, and I'm going to stop it because I need to explain what is happening here. So we have Wireshark divided in like 3 sections. We have first a lot of packets here. So when we're talking about the packet list pane, so it's this whole section of packets in the packet flow. And then we have like in the packet selection pane, so if we select a random packet, let's say this EDP packet, yep. So we have here the packet details, and then we have the packet bytes pane. So both are for details of the packet, but in different formats. Here you have like in different layers what the packet does, or the data from the packet. So in which frame, the encapsulation, the size, the protocol you use. You have if it's TCP, how the handshake was, or what size or what number of the handshake was, if it was the synchronized, the acknowledge, or the synchronized acknowledge. And here you will have details and have ASCII of what is the details are. If we had like an HTTPS packet and this wasn't encrypted, you will see the raw text. But in this case, it's an UDP packet. So if we wanted to continue capture, to initiate the capture, you just click on here. We're not going to save this time. So, and you see the packet flowing. It does flow like a whole lot. Here we're gonna stop it at this time, and we can even restart the packets. And this way we can just go on and on until we have all the packets needed.
Another thing we need to think about it in using Wireshark is the filters. The filters are commands, flags, and keywords we can use for show only the packets we are interested in. Imagine you are on a big network or an enterprise network, and you have like 100 devices, and you have also 100 or more IP addresses. You will be able to see on Wireshark. But the problem is that, as we already see with Nico, is that we can receive a lot of packets in a single seconds. For that reason, we need to use filters for the packets. For example, imagine you already make a ping command um, using the ECMP protocol, that it means Internet Control Message Protocol. For example, in my case, my IP address is right here. It starts with 10 and ends with 15, and I just make a ping to the DNS IP address of Google. So we can look for these specific packets. We already generate. For example, type in my specific address, and remember, these commands, these flags, or these keywords are on the Wireshark documentation. For example, my IP address is right here. Can I use copy and paste my IP or filter all the packets, and only the packets that contain this specific IP will be shown. But for example, ECMP packets we already sent and received, we can just type the specific protocol ECMP, and the packet will be shown. That's pretty easy. Another thing we need to know about Wireshark is the kind of information that is being shown. For correctly analyze the packets we capture, we need to know that the packets itself are just a piece of information that are encapsulated and de-encapsulated on many layers. For example, let's look for some TCP packets. In this one, the number 24, we can find some important information about like the time. The time is just the specific moment when the packet was sent or received. We have the source. Actually, the source is just the address that is sending that specific packet. Destination is the address that will be received that packet. The protocol, as we already see, is the specific protocol we use for send or receive this packet. The length is how long is the packet. Finally, we have info. This port is show general information about the packet. We can see, for example, in this packet, the source port and the destination port. It just resume of the information content on the packet. As you can see, the ports are listed here. So this resume of the information, it allows us to quickly identify unsecure ports, default ports, or maybe that some service we are running on our machine is using a dynamic port. I don't know, there are many scenarios, and you need to know how to use the general information of the packet.
Now that we're reaching the end, here are 3 real-world uses for Wireshark. The first one being detecting suspicious traffic, which is finding unusual connections or spikes in data. The second one would be troubleshooting, which is solving network problems or monitoring communications. The third and final one would be malware investigation, which consists in seeing how an infected system communicates with others.